over PXCM 7005 that does the chiller control. So this controller here, and actually all the controllers in this building are all BACnet controllers. So it's the same as all your new buildings that are going on. They're communicating BACnet. So they will show up a little bit different. The main new graphics that you will be getting for this building are all going to be on Desigo. We have some limited ones on Insight, and we'll get some of those cleaned up, you know, here in a little bit. The whole server thing has really delayed our graphics even more than we were behind already. So the inside here is a PXCM. There's also communications from here to each of the 4 chillers. This controller also communicates to the DEMs on the main switchgear and your ATSs for your generator. It's kind of the same as our old FLN, but it's BACnet MSTP. Master, slave, token, passing. MSTP. Changed the pumps, which I'm sure Sid's probably already aware of that. You know, they left, the project didn't include any new pumps on hot water or any of these new pumps. You got a couple new pumps for the boilers. When we get to the boilers, I'll show you that. I think those 2 pumps are new, and you have some new pumps for the heat recovery system. The cooling tower is up on the roof, and we'll actually get to that. We have a controller in that penthouse up there that actually controls the cooling tower. I mean, assuming in the spring you're probably going to get. Actually, you guys don't usually go to the chiller training, right? Did they ever do it?
Yeah,
he did it with the rest of his guys, right?
Yeah, it just needs to get restarted up again.
Yes.
Right.
They were started late, and we couldn't put a real good load on them. So
Were you planning to use pumps then?
we ran them.
Okay.
Yeah, we had the system up and running.
Okay.
Brad from Tri-County was able to start up and do the full startup in each individual chiller. We ran into some issues with the metal, the rust and stuff in the cooling towers, plugged up all the cooling towers. We had to stop running it.
It was vibrating the pipes, right?
It was all the way down here. I mean, it was scary down here. These pipes here were jumping because it couldn't get the flow out of the tower. Any questions on the chiller stuff? It's a little bit further away, but we had issues. There's no good place to put it over there, so we had to mount the controller here. On the other side of the controller is the Aerco control, the ACS, and the Aerco valve controller. Our electrician installed it, but we didn't provide it. We integrate to it.
Okay.
We also have the proto node down here, which is part of the ACS, or part of the Aerco boiler system. This is how we talk to it. It converts, BACnet to Modbus, and then talks Modbus to the boilers. Same thing, we have our UPS down here. This, actually, I didn't say it over there. We have these are 5-gang transformers. So there's 5 100 VA transformer circuits in here. Typically, you should have, on a cabinet like this, probably 2, maybe 1 or 2 extra circuits available for future, which is kind of nice because they always get used up before we're done. This cabinet also has, because your boiler room, your mechanic room set up, the boilers are here. You got the 2 boiler pumps over there, but then on the whole other end of the mechanic room, you have the pumps that feed the hot water to the building. The existing pumps have been there forever. They took out the heat exchangers. You used to have a couple heat exchangers that would convert from medium temp from the other building over and then down, and then have it isolated. They removed those heat exchangers. A lot of the piping is the same. Everything past the pumps is all the same piping. Even out in the building, it's all pretty much all the same existing piping. So we have down in the far wall, we have another cabinet and it's actually labeled, it's a sub cabinet of this. So even though it's a whole nother enclosure, you open it up, there will not be a controller in here. It just has modules. Those are actually part of this cabinet. Just made it easier, makes it easier for you in the future if you want to add stuff. You have another place to closer, shorter runs to run wire. When we get to the air handler, we did the same thing with the air handlers. So there's 4 boilers, 2 boiler pumps. As far as the boilers go, we need to try to maintain minimum flow for the boilers. We have a flow meter in line. We have issues. There's issues with flow issues. So when we go to turn on, if Aerco calls for 3 boilers, we can't give that pump without pumping enough water to flow. I think it has had issues. Needs 150 GPM per boiler, and the most we can get out is maybe 400. 3 would probably run, but I think 4 you'll start getting some issues. So we have a mag meter in the back, because I think somebody asked a question a while ago, why is the boiler pump always running full speed? So, okay, I think you asked Jason and Jason asked me. So the reason is, we don't control the boilers, we enable the boilers, we want heat. Aerco says, okay, I need to run 2 boilers. Aerco opens the isolation valves on the 2 boilers. I get an end switch that says the valve is open. I need to maintain a certain amount of flow for those boilers, so I ramp it up. So once I get, I think it's 150 GPM per boiler. So anytime there's more than 2 valves open, I ramp those pumps to 100%, because anything else, I'm trying to control water flow that I can't achieve. You know, it wants GPM, I can only get 400. I think it's 400, somewhere around there. Are you on the system right now or not?
I'm trying to get it out.
What's that? No, it's designed to run all 4. It's just, I think it has an issue with, I think the piping actually goes up and over top the air handler and all the way around. I think the pumps can't overcome the head pressure.
I thought that's how it was, but I thought eventually when those opened up, you were able to get it last time we tried it.
You think so?
Yeah, I'm almost certain they ramped right up.
Okay, maybe it was flow restriction.
It was really close.
I can't tell more to run. I don't know how many are open right now. We can look at Jason when he's not recording if we want.
Sounds good.
So as part of that same system down there, there's 3 pumps, 3 existing pumps. They got new speed drives. One pumps that's supposed to be the reheats. One pump pumps all reheats. The other pump pumps the fin, and they put a bunch of reheats on it. Because something about the pipe sizing and the existing pipe sizing, the engineer had them add reheats to it. So we really can't reset the fin like we're supposed to be able to, because you have reheats on it. Because reheats need full temperature. The fin want to reduce temperature, but they intermix. So there's no true fin loop and reheat loop anymore. So you can't shut off the fin in the summer like you used to be able to. You got to run that fin loop year round for dehumidification.
So like when we close valves, they have valves we close?
The control valve should close. Now you probably have some areas that, I don't know about some of the fan coils and stuff. There's old fan coils that they didn't touch that they have no controls because they were pneumatically controlled, and you have no air in the building anymore. So there's several of those in the building. So at some point you're going to want to go and try to figure out how to do something there to make those work, because they have pneumatic air valves. We have no pneumatics, so the valve is going to be wide open year round on those, and they will get heat because they're going to be on you can't turn the loops off. I think that's it.
Pump upstairs too, right?
We'll show you upstairs. There's a little pump on the fin loop to be able to reset one little area. Something your engineer wanted.
If the pump dies, you don't get heat, right?
Correct. Pump and a valve and a sensor. It was to try to there's an area upstairs, the fin tube, they couldn't get it off the fin tube loop, so they took it off I think they took off the radiant loop, or the reheat loop. So that's right, so it's both loops are intermixed. So you have the existing reheat loop, and then the Delta had them put some fin on that reheat loop. So then they put this little thing in to try to reset the fin, so you wouldn't get the full temperature through that fin. Because I guess the rental, they don't want the hot water through that. So 7003 controls both air handlers. So this is air handler number 1. Air handler 1 has 4 supply fans and 2 return fans. So the way these systems are is the supply fans are over here, the return fans are over in that return air plenum over there, and they track each other. So as the fans ramp up, we ramp up the return fan to try to balance the pressurization in the building. I think they're like 50 horse fans, 25 horse fans. Big fans in there. At some point when they do the fan training, you guys you'll get to see all that. Pretty much the same as we do with any other air handler anywhere else. We got outside air on the end, return air comes in up on the top. We have airflow stations. The displays are on the side of the air handler. They're out by the outside air intake. This system has a heat recovered coil, so it pumps glycol from the heat recovered coil down to the exhaust air plenum down there. And all the return air gets blown from those fans. If anything we're exhausting, it goes through those coils and tries to pick up any type of heat it can to preheat the air as it's coming in from outside. So a little different than a heat wheel, it's actually pumping glycol. Picking up heat down there, bringing it over here to the air handler, letting the outside air go through it, preheat the air a little bit. Inside the air handlers, because they're so big, we have multiple sensors. Mixed air sensor, there's four temperature sensors, and we wire them 2 in series with another 2 in parallel. I have run into it before because it's just too much area to have one temperature sensor to pick everything up. There's probably 4 low limits, I'm assuming. Do you remember, Jeff? It's such a big area. So if a low limit were to trip, there'd be 4 spots that could have reset buttons. They're all on the outside of the air handler. Inside. Do you want to go down there and check? Go check on that one. We try to keep, because these units are big, thick enclosures, we try to limit our penetrations through them, because every time someone drills a hole through the side of an air handler, it's just a place air can get out. Lose your pressure. So most of the controls are installed in the compartments inside the air handler. We also have, very similar to the boiler system, we have an expansion panel that runs air handler number 2. Right outside air handler number 2 is another enclosure. That enclosure is truly part of this controller. One controller here controls the modules over there. UPS on both air handlers, 5-gang transformer, all of our different circuits come up here. Probably have. Oh no. Inside here we have it labeled which circuit does what. Airflow stations, dampers, and valves. So if you have a problem with a damper, you can go here and we can troubleshoot the 24 volts from this transformer. Airflow stations, if you have the airflow station that's not working, same thing. It has its own, one transformer serves all the airflow stations on this air handler. Valves, control valves up high. This is a big, high, tall mechanical room. You get down the side of this unit, you can see that there's one up there. That's a bypass valve for the chill water system. But up over top of the air handler are the control valves for the actual air handler. So you're gonna have to have pretty big ladders to get to some of the stuff. That one there really has a tough time. Can't build up any static. It doesn't. Maybe in the winter, if you're a real low airflow, you can build up enough static to satisfy the VAVs, but just because of the difference in size. If you actually follow the ductwork out, it's kind of going over it with sit a little bit. So you see here, this everything on this end is supplied. So that's a supply duct going to that one section of the building. This is a supply duct going to a different section of the building. Off air handler 2, you got supply duct going to a different part of the building, and off the other end is 2 supply duct going to that end of the building. So supply air from this air handler, you know, goes up that duct, goes up this duct, goes over, goes through air handler 2, and goes up 2 branches of the duct over there. So when you try to run air handler 2 by itself, that has to push all that air over here through this air handler and then out, and it just struggles. So far we've run 2 just to do the balancing and stuff, but besides that I haven't run it. Because the way the ductwork's not is, you know, if it was headed out here further, it'd be easier for that to go, but it's just a tough path for the air to go. We run air handler in 1, that end of the building might get air, but you just don't get the air up, you know, where it has to come over, go through this air handler, and then out. I don't know, any questions on the air handler?